we're going to talk about two types of covalent bonds, and how we're going to distinguish between those is we're going to be looking at their electronegativity values of the nonmetals. So we know that electronegativity is the ability of an atom to attract electrons in a bond or in the presence of another atom. This property is going to influence how electrons are shared between two nonmetal atoms. So the first type is called a nonpolar covalent bond. This occurs between two nonmetal atoms with an electronegativity difference of 0 to 0.4. So it has to be 0.4 or less when we subtract each atom's electronegativity from the other. If we have this range and we have a nonpolar covalent bond, we say that the electrons are shared equally. So each nonmetal is of similar strength to each other, so they're able to share them equally. So here we have three different examples. Between two fluorines, so 4.0 minus 4.0, we get 0.0. So F2 and O2 in any of the diatomics are all considered nonpolar covalent bonds because you get an electronegativity difference of 0. If I look at the difference between one carbon and one iodine, so we have 2.7 and 2.6, I get an electronegativity difference of 0.1. So that falls within that range of being 0.4 or less. So in this case, the iodine and the carbon are going to share those electrons equally between them. Now a polar covalent bond is generally going to be greater than 0.4, and we usually say it goes up to around 1.7, but if we have two nonmetals and it's greater than 0.4, we're going to label it as a polar covalent bond. This means that electrons are shared unequally. And this is due to the fact that one of the two has a greater electronegativity than the other one, which allows it to attract the electrons to it better. So electrons are going to spend more time around that more electronegative atom, and it actually creates this partially negative charge around it, and the less electronegative atom becomes slightly positive because the electrons aren't around it as much, so it develops slightly positive charge. You can see here in the picture where chlorine, which has that higher electronegativity, is going to be able to pull those electrons closer to it. So with these three examples, even though we have H2O, we're only looking at the bond between an oxygen and one hydrogen. So oxygen is 3.4 minus hydrogen is 2.2, so we get an electronegativity difference of 1.2, which is much greater than that 0.4. So we have a polar covalent bond between the one oxygen and one hydrogen. Between a nitrogen and hydrogen, we get 0.8, so we have another polar covalent bond. And if I look at the difference between carbon and chlorine, 3.2 minus 2.6, I get an electronegativity difference of 0.6. So still greater than 0.4. So in all of these bonds, we are unequally sharing electrons, so we have a polar covalent bond. Another thing I want to bring up in this topic is something called bond character. So when we're calculating these differences in electronegativity values, we can talk about them in a much more general sense. I can ask about what has the most nonpolar character, the least ionic character, and it all comes down to calculating the differences in electronegativities. Bonds that have a small difference in electronegativity, we would say, have the most nonpolar character, but will have the least polar character and the least ionic character. Molecules that contain bonds with a large difference in electronegativity we would refer to as being the least nonpolar character or the most polar or ionic character. And I'll go over some examples of this, but I want to make sure you at least have this little chart in your note packet to refer to tomorrow when we look at some multiple choice questions. Okay, you're all set.